Hello and welcome to this video on software engineering for cloud computing. In this segment, we will provide an overview of what software engineering for cloud computing is all about. Cloud computing has revolutionized the way we use and access computing resources. It has made it possible for individuals and organizations to access computing resources on demand without the need for expensive hardware and software infrastructure. However, with the benefits of cloud computing come new challenges, especially in the area of software engineering. Software engineering for cloud computing is the process of designing, developing, testing, and deploying software applications that are optimized for cloud computing environments. This involves understanding the unique characteristics of cloud computing, such as scalability, elasticity, and fault tolerance, and designing software applications that can take advantage of these characteristics. In this video, we will cover the key concepts and best practices of software engineering for cloud computing. We will discuss the different types of cloud computing models, such as infrastructure as a service IaaS, platform as a service PaaS, and software as a service SaaS, and how they impact software engineering. We will also cover the different stages of the software development lifecycle, such as requirements gathering, design, development, testing, and deployment, and how they are adapted for cloud computing environment. We will discuss the importance of DevOps and continuous integration/continuous deployment CI/CD in cloud computing, and how they can help streamline the software development process. Finally, we will discuss the importance of security and compliance in cloud computing, and how software engineering practices can be used to ensure that applications are secure and compliant with industry standards and regulations. So, let's get started and dive into the world of software engineering for cloud computing. In this segment, we will discuss the different types of cloud computing models and how they impact software engineering. Infrastructure as a service IaaS is a cloud computing model that provides virtualized computing resources, such as servers, storage, and networking, over the internet. IaaS allows organizations to rent computing resources on demand without the need for physical hardware. This model is ideal for organizations that want to have complete control over the computing environment, including the operating system and applications. Platform as a service PaaS is a cloud computing model that provides a platform for developers to build, test, and deploy applications. PaaS providers offer a pre-configured platform that includes an operating system, programming language, and development tools. This model is ideal for developers who want to focus on building applications without worrying about the underlying infrastructure. Software as a service SaaS is a cloud computing model that provides software applications over the internet. SaaS providers host and manage the software application, and users access it through a web browser or mobile app. This model is ideal for organizations that want to use software applications without the need for installation, maintenance, and upgrades. Each cloud computing model has its own unique characteristics and impacts software engineering in different ways. For example, IaaS requires software engineers to have a deep understanding of the underlying infrastructure, including virtualization, networking, and storage. PaaS requires software engineers to have a deep understanding of the platform, including the programming language and development tools. SaaS requires software engineers to have a deep understanding of the software application, including its architecture and user interface. In the next segment, we will discuss the different stages of the software development lifecycle and how they are adapted for cloud computing environments. In this segment, we will discuss the different stages of the software development lifecycle and how they are adapted for cloud computing environments. The software development lifecycle (SDLC) is a process that software engineers follow to design, develop, test, and deploy software applications. The SDLC typically consists of the following stages: requirements gathering, design, development, testing, and deployment. In cloud computing environments, the SDLC is adapted to take advantage of the unique characteristics of the cloud, such as scalability, elasticity, and fault tolerance. Requirements gathering in cloud computing environments involves understanding the specific requirements of the cloud computing model being used, such as IaaS, PaaS, or SaaS. This includes understanding the scalability and elasticity requirements of the application, as well as any security and compliance requirement. Design in cloud computing environments involves designing the application architecture to take advantage of the scalability and elasticity of the cloud. This includes designing the application to be modular and scalable, and using cloud-specific services, such as load balancers and auto-scaling groups. Development in cloud computing environments involves developing the application using cloud-specific tools and technologies, such as Amazon Web Services, AWS, or Microsoft Azure. This includes using cloud-specific programming languages, such as Python or Java, and using cloud-specific development tools, such as AWS Code Deploy or Azure DevOps. Testing in cloud computing environments involves testing the application for scalability, elasticity, and fault tolerance. This includes using load testing tools to simulate high traffic and ensuring that the application can handle sudden spikes in traffic. Deployment in cloud computing environments involves deploying the application to the cloud using tools such as AWS Elastic Beanstalk or Azure App Service. This includes configuring the application for scalability and elasticity and ensuring that it is secure and compliant with industry standards and regulations. In the next segment, we will discuss the importance of DevOps and continuous integration/continuous deployment CI/CD in cloud computing. In this segment, we will discuss the importance of DevOps and continuous integration/continuous deployment CI/CD in cloud computing. DevOps is a set of practices that combines software development dev and IT operations ops to shorten the system's development lifecycle and provide continuous delivery of high-quality software. DevOps is important in cloud computing because it helps to streamline the software development process and ensure that applications are delivered quickly and reliably. Continuous integration/continuous deployment CI/CD is a set of practices that automate the software delivery process. CI/CD is important in cloud computing because it helps to ensure that applications are delivered quickly and reliably, and that they are scalable and elastic. In cloud computing environments, DevOps and CI/CD are used to automate the software development process and ensure that applications are delivered quickly and reliably. This includes using tools such as AWS Code Pipeline or Azure DevOps to alternate the build, test, and deployment process. DevOps and CI/CD also help to ensure that applications are scalable and elastic. This includes using tools such as AWS Autoscaling or Azure Autoscale to automatically scale the application based on demand. In addition to automating the software development process, DevOps and CI/CD also help to ensure that applications are secure and compliant with industry standards and regulations. This includes using tools such as AWS Config or Azure Security Center to monitor the application for security vulnerabilities and compliance issues. In the final segment, we will discuss the importance of security and compliance in cloud computing and how software engineering practices can be used to ensure that applications are secure and compliant. In this final segment, we will discuss the importance of security and compliance in cloud computing and how software engineering practices can be used to ensure that applications are secure and compliant. Security and compliance are critical in cloud computing because organizations are responsible for protecting their data and ensuring that their applications are compliant with industry standards and regulations. This includes ensuring that data is encrypted both in transit and at rest, and that access to data is restricted to authorized users. Software engineering practices can be used to ensure that applications are secure and compliant. This includes using secure coding practices, such as input validation and error handling, to prevent security vulnerabilities. It also includes using tools such as AWS Identity and Access Management (IAM) or Azure Active Directory to manage access to resources. In addition to secure coding practices, software engineering practices can also be used to ensure that applications are compliant with industry standards and regulations. This includes using tools such as AWS Config or Azure Policy to monitor the application for compliance issues, and using automated testing tools to ensure that the application meets industry standards. Finally, it is important to ensure that the cloud computing environment itself is secure and compliant. This includes using tools such as AWS CloudTrail or Azure Security Center to monitor the cloud environment for security vulnerabilities and compliance issues. In conclusion, software engineering for cloud computing is a critical discipline that helps organizations take advantage of the benefits of cloud computing while ensuring that their applications are secure and compliant. By understanding the unique characteristics of cloud computing, such as scalability, elasticity, and fault tolerance, and using software engineering practices such as DevOps and CI/CD, organizations can build and deploy applications that are optimized for the cloud. Thank you for watching this video on software engineering for cloud computing.